there's been some very interesting data coming back from the Red Planet. NASA's Curiosity rover has been on Mars for almost 7 years, and in that time, it's performed numerous experiments and made many discoveries, teaching us a lot about the Martian surface and its chemical composition. One particular thing that the Curiosity rover has noticed several times now is methane. Methane is a small molecule composed of a single carbon atom bound to 4 hydrogen atoms. It's basically the smallest organic molecule there is, and it could be a sign of life. Now, before I get carried away with extraterrestrial optimism, methane can be generated from geological processes, like serpentinization, or from raw magma cooling into rock. However, serpentinization requires liquid water, and raw magma requires tectonic and volcanic activity. Mars is unlikely to have these resources in any great quantity. Another way that methane can be generated is biologically, through some kind of metabolic chemical process. On Earth, this biological methanogenesis is mostly performed by species of methanogenic archaea. So with this in mind, it's particularly interesting that NASA's Curiosity rover has recently detected a large puff of methane, the most concentrated puff ever recorded on Mars. In 2004, the European Space Agency determined that Mars had methane in its atmosphere, up to 10 parts per billion. In 2011, NASA refined that estimate to about 7 parts per billion. They also found methanol at up to 19 parts per billion, and similar concentrations of ethylene, formaldehyde, acetylene, and a variety of other tholins and small reactive compounds, including several nitrogenous compounds. Atmospheric and orbital measurements in 2013 and 2014 would find that Mars has seasonal increases and decreases in methane concentration. Personally, I think that this is evidence that supports the hypothesis of there being some kind of methanogenic microbial ecology on Mars, with its metabolic activity accelerating in the summer and decelerating in the winter. It's in rhythm with the seasons and the temperature cycles of the planet. Now, after the Curiosity rover landed in 2012, it started roaming around, taking air and soil samples. Using the concentration of methane at the landing site as a baseline, which was less than 1 part per billion, the rover would go on to detect multiple spikes in methane concentration, suggestive of some kind of leak, or that the rover is passing by some kind of concentrated methanogenic source. The first spike that it detected was in 2013, when it seemed to drive through a cloud of methane at 7.2 parts per billion. Now, most recently, in mid-2019, Curiosity detected another spike in methane, at 21 parts per billion. These bursts of methane raise a lot of questions, like, how likely is it that this methane is geological in origin? Serpentinization and cooling magma existed on Mars a long time ago, so any methane that was generated by those processes would have, or should have, broken down by now. It should have been decayed, especially with all the UV radiation in Mars's thinner, less protective atmosphere. This UV radiation would break down the methane by knocking off hydrogen atoms, leaving behind reactive carbon atoms. Is this methane biological in origin? This would be the most exciting outcome, but even if this was the case, there's a few possibilities within this outcome. This methane could be generated by organic-rich clay deposits decaying. If this is the case, then the clays could be composed of a mixture of tholin ices and other organic compounds. Basically, the clays would just be a wad of simple biomolecules compressed together. Or, alternatively, the clays could be the organic residues of long-dead organisms, like the Martian equivalent of ancient trees being compressed into coal. This would be super cool because it would be direct evidence of past life on Mars. Another possible outcome is that this methane is being generated by some kind of methanogenic Martian microbe, which, if this is the case, if this is true, it would be really big news. This could be the first evidence of life on another planet. Then we would have to ask if this is native Martian life that's fundamentally different from Earth life, or if it's carbon-based life like Earth, or if it's the descendant of Earth microbes having been ejected from Earth after a meteor impact a long time ago and landing on Mars. Or if this life is related to the progenitor of Earth life, from an impact event long ago that blasted Martian microbe-laden rock from Mars to Earth. If this latter possibility is the case, then that would mean that life in the solar system originated on Mars, and only through the happenstance of astronomical collisions was some of that life spilled onto Earth. And so, in this sense, if we do detect Martian microbes, and they are native to Mars and Earth life is descended from them, then this Martian life would be like our long-lost cousins. Or I guess, from their perspective, we would be their long-lost cousins, because long ago, some of their cousin Martian microbes were blasted off the planet to go seed the Earth. However, I am getting way ahead of myself. All that's been discovered so far is a burst of methane coming out of the surface. All of this stuff about life, about seeding Earth or Martian nativity, this is all speculation. Until curiosity digs into the dirt to take a sample, study it, and find some kind of weird alien microbe generating methane, this will stay speculation. However, this time, it feels like we're really close to the big discovery. I want to be optimistic. I think it's very probable that these methane plumes could be generated by alien life forms. It's distinctly possible, but as with most groundbreaking scientific discoveries, we'll just have to wait for more study and more analysis before we can know for sure.